Welcome to doassignment-ca. Here is the problem. A 10-pound block has a speed of 4 feet per second when a horizontal force F equals 8t squared pounds is applied. Determine the velocity of the block when it has moved s equals 30 feet. The coefficient of kinetic friction is mu sub k equals 0.2. Now let us work through the solution step by step. Let's start by listing everything we know. We have a 10-pound block moving at 4 feet per second when a time-dependent force of 8t squared pounds is applied horizontally. We need to find the velocity after 30 feet of travel. The mass is 10 divided by 32.2, giving 0.316 slugs. Because the force depends on time rather than position, we will use the impulse-momentum method combined with kinematics to relate time and displacement. From the free body diagram, vertical equilibrium gives the normal force equal to the weight, which is 10 pounds. The kinetic friction force is 0.2 times 10, giving 2 pounds opposing the motion. Applying Newton's second law horizontally, the net force is 8t squared minus 2, and this equals mass times acceleration, where mass is 10 divided by 32.2 slugs. Solving for acceleration gives a equals 32.2 times the quantity 8t squared minus 2, all divided by 10. Separating variables and integrating both sides, with lower limits t equals 0 and v equals 4 feet per second, we get 10 over 32.2 times the quantity v minus 4 equals 8t cubed over 3 minus 2t. Solving for v gives v of t equals 4 plus 3.22 times the quantity 8t cubed over 3 minus 2t in feet per second. Integrating the velocity expression term by term from 0 to t gives displacement as s of t equals 4t plus 3.22 times the quantity 2t to the fourth over 3 minus t squared, measured in feet. Setting this equal to 30 feet produces a nonlinear equation in t that we solve numerically. Evaluating the displacement function at trial values. At t equals 2 seconds, s is approximately 29.47 feet, just under 30. At t equals 2.02 seconds, s is approximately 30.68 feet, just over 30. Linear interpolation between these two values gives t approximately equal to 2.009 seconds when the block has traveled exactly 30 feet. Substituting t equals 2.009 seconds into the velocity formula, t cubed is approximately 8.108, so 8 times t cubed over 3 is about 21.62, and 2t is about 4.018. The velocity is 4 plus 3.22 times the quantity 21.62 minus 4.018, which equals 4 plus 56.69, giving approximately 60.7 feet per second. Checking with the work-energy theorem, the initial kinetic energy is about 2.49 foot-pounds, and the final kinetic energy at 60.7 feet per second is about 572 foot-pounds. Friction does negative 60 foot-pounds of work over 30 feet. The applied force, therefore, must have done about 630 foot-pounds of work total, which is physically consistent with a rapidly growing force applied over roughly 2 seconds. The result is confirmed. To summarize, the normal force is 10 pounds and friction is 2 pounds. We wrote the equation of motion and integrated it once to get velocity as a function of time, then again to get displacement as a function of time. Setting displacement equal to 30 feet gave a time of about 2.009 seconds. Substituting back into the velocity equation yields the final answer. The velocity of the block is approximately 60.7 feet per second after traveling 30 feet. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.